So hey guys, welcome back to my channel. Hope you're doing extremely well. And this is your very own mask code at this side. And today we will be solving yet another problem of POTD. So today's problem is largest subsquare surrounded by X. So without wasting any further time, let's see what does the problem say. Okay. So the problem says that you have been given a matrix, an n by n matrix that is equal number of rows, equal number of columns. Okay, and you have to find me the maximum side that can be formed of a square such that the boundary of the square is containing x only. Like it can contain x or 0, but the square boundary should contain x only. Okay, so let us identify the squares that are present here. So if we try to identify the squares which are present here, that can be, this is a square, right? This is a square. This is square of side 1, right? Similarly, all the elements of x are square, right? You can mark them up on your own, right? Another square is this one. You can see the boundary of the square is only surrounded by x. It doesn't matter what is on inside, it is 0, but the boundary is x. So we are just concerned about the boundary. So you can see it is the side of this square is 3 and the side of this square is 1. So what is maximum? It is 3, right? So we have to return 3 as our answer. We have to return 3 as our answer, right? So this is our input and output scheme for this question. Now, how can we solve this? So one brute force approach that comes to my mind is brute force approaches start from here, right? And now for this index, check if this is possible, if this is possible, if this is possible, if this is possible, right? And then move to second index. So second, check if this is possible, if this is possible, if this is possible. Only these three are possible in the case of second one. Similarly, find it for all elements, right? So how much time it will consume? How much time it will consume? So to check this, the time it will consume is it is forming all of the matrix, right? For the first element, how many times it is taking? It is one, two, three, four. Four squares are forming, and how many times it is traversing? So it is traversing single element once, then one, two, three, four. That is the size of four, right? Then one, two, three, four, five, six, seven, eight, eight, right? Up till n. That is, it is taking log n time, right? For one, it is taking log n time for one. There are n square elements, so it is taking n square log n. Pretty inefficient, right? Pretty inefficient. What can we do to save this time, right? What can we do to convert this time into an optimized one? For that one, we will be looking at an optimized solution. Optimized solution, right? Optimized solution says that, hey, I will give you the less time complexity, but you will have to take O of n square space complexity. I'll say, okay, show me the one with the less time complexity. Okay, so you will say construct two matrices of same order. So order of this matrix is 4 into 4, right? I will construct the two matrices of same order. You can also create a 3D matrix to store both of them at one place only, but the space complexity will be even. I am just using two matrices to what do they facilitate the process, right? He will say that form the mat like it is named as by rows, it is named as by columns. This matrix is named as by rows. This matrix is named as by columns. So he will say in by rows ij is equals to maximum side horizontally that can be formed ending at I comma j. What does that mean? So if I'm moving from this direction to this direction, what is the side that can be formed maximum on this 0 0 index? You will say 1 because this is the only index that, so I will mark it 1. Moving here, you will say the maximum side that can be formed is this 2. Now this 3. Now this 0. So in case of 0, it will convert to 0, right? Because it is not x. So what will we do? 0. Okay. Similarly, for this one, 1. For this one, again 0. For this one, now it will start from 1 again, because you can see the maximum side from in the left can be 0 only. So it will be 1. Similarly, 2 here. Now 1, 2, 3, 0 again, and 1, 0, 1, 2 again. That bottom two rows are identical, right? Okay. Similarly, the by column states that by columns ij equals to maximum side, rest all the things are same, vertically ending at ij, right? Similarly, by column we will be taking this direction. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 0, 1, 0, 1, 0, 1, 0, 1, 2, 3, 4, 1, 2, 3, 4, 1, 0, 1, 0. Oh, sorry, 0, 1, 0, 1, right? 0, 1, 0, 1, right? Okay. Now I will say, what is the space complexity up till now? Space complexity up till now is O of n square for this, O of n square for this. So total O of n square up till now. Okay, now I will say start traversing. Start the traversal. You will say in what direction? In what direction? I will say from bottom right, that is n minus 1, n minus 1. That is this element, to top left, that is this element 0 comma 0, right? And what do? We keep our answer as a result. We keep our result as starting at result equals to 0 for the case when there is no x in the matrix, right? We are here, right? We are here. Now what is the maximum side of square that can form, that will be including this vertex as a corner, that will be including this vertex as a corner, as a bottom left, bottom right corner. Okay, what I'm saying is maximum side of square that can be formed using uh, the ij that we are still at as bottom right corner, right? So we are doing the traversal. Let's say the loop is known as traversal. That is easy to do, right? We will use two loops, nested loops to traverse, right? Traversal, and this loop is currently at ij. Now, what is the maximum side that can be formed? So we will say this has two as a by rows, one as its column. That is, in if I go vertically, if I go horizontally, I can form a size of two. But if I go vertically, I can form a size of one. So what you will choose? You will choose two or you will choose one? You will choose one. Why? Because one is less than two, right? First of all, and if two is possible here, one is possible here. You can also say that you can see that for a square the sides will be equal. So it is not accessible to make two, but it is accessible to shorten two to one, right? So this will be my square. This will be my square, right? So my side will be minimum of by rows ij, and sorry, not this is by calls means by columns ij, right? Okay, this is my side, right? Now if I confirm that this is my side, I confirm that this is my side, right? Now my side comes out to be 1. Is it really possible, that is it really true, like if I get this as 1, let's just take a complex case. Suppose if this I get as for 3, let's say, if the minimum side I get is 3, right? So it can be the case that x what is it is 1 2 3 x, so it is also 1 2 3, so both of them are giving 3, right? I choose this corner as for side 3. Now this might be possible that this is happening. Now it doesn't guarantee about that, so we will have to check whether this side square is still possible, whether this side square is still possible. So we will run a loop. Now why should we run a loop? Like what is the circumstance that we should run a loop? If side is greater than result. See, if we have already achieved a size of 3 and we are trying to form a side of 2, right? So what is the point? So what we will do is, we're standing here. First we will check, if I mark the indexes of this, so it is 1 for horizontal and 1 for vertical, 2 for horizontal and 1 for vertical, 3 for horizontal, 3 for vertical, 3 for, this is same, 2 for horizontal, 2 for vertical, and 1 for horizontal, 1 for vertical, 1 for horizontal, right? So what is the case I need to do? So if this would have been a valid square, so what is the case if this would have been a valid square? This is 0. I don't care about this. This can be anything, right? Okay, so now what is this? It is 1 1 1 2, sorry, 2 1 3 1, right? I'm mentioning by rows first and by columns at last position. Now it is horizontally 1, vertically 2. This is horizontally 1, vertically 3. This is horizontally 2, vertically, you can see it is 0 again, so 1. It is saying horizontally 3, horizontally 3, vertically 3. This is horizontally 1, vertically 2, right? Okay. What I will say is, I want a side of 3. So if I want a side of 3, I will see 1, 2, 3. I will check it here, right? I want a side of 3. So for 3, its vertical, its vertical should also be 3, right? If this is a side of 3, its vertical should also be 3. Okay. Find the vertical of 3. It is 3. Okay. Now, for this to be 3, this should be true, and this should be true. For this to be true, for the 3 to be true, this should be true, and this to be true. Right? 3 comma 1. I will check 3 for this, I will check this 3 for this. Right? 3 comma 1, 3 comma 1. I got it. So my side will become 3. Right? And my result will become 3 from it. If it was smaller than side previously, right? So let us understand once again. Let us deeply understand what is happening. So I am saying that you have a matrix x x x x x x x x x x, right? Suppose this is 0 0, right? I'm saying, tell me the by rows and by columns of each of them, right? Now I want to consider only this matrix as my traversal. Why? Because while traversing I have reached here somehow, and when I have reached here, I will say that the matrix I'm concerned with is axiom matrix, that is this one, right? So let me say what is the by rows and by calls. So it is 1 comma 1 for this one, 2 comma 1 for this one, 3 comma 1 for this one. Now it is 2 comma 1 for this one, 2 comma 2 for this one, 3 comma 2, 2 for this one, 3 comma, yeah, 3 comma 2. This is 3 comma 1 for this one, 3 comma 3, sorry. It is 1 comma 2, 2 comma 2, and 3 comma 2, right? Now it is 1 comma 3, 2 comma 3, 3 comma 3, right? I say I'm here, the side comes out to be minimum of these two, that is 3. Now, for this to be true, for this 3 to be true, this value should also, this values by calls should also be equals to 3. And this value by calls should also, by rows should also be equals to 3. Why? If this is 3, that means that these 3 are present. And if this is 3, that means if these 3 are present. And these 3 are present, that is why this was 3. Right? So if I find this 3, if I find this 3, if I find this 3 as this one, a square is formed. Right? That was my condition, right? What was I doing? I was just checking if this is not a case like something like this. If this is not something like 0 0 0 0 and x x x x. But I'm getting 3 only because of these elements. There is no element present here as x. Right? This was my whole scenario. Right? So what will I do? I will say that check the element on the what? Right, I will say that I've got my side address. Sorry for doing it here. Let me write the pseudocode between at the bottom. It is traversal of ij, right? Side equals to, we found the minimum, right? Now till what I will do? Suppose my result equals to 2. My result equals to 2, right? And this 3 comes out to be false, and then I move my side to this. So I will check this one, right? This 2 also returns me false for some example, and now I'm here back to 1. Now should I check 1? Why will I check 1? If it is already 1 and I have already got an answer bigger than 1, why will I check? So what I will do is, while side is greater than result, that is I can expect a greater answer from here, then what will I do? I will say, if this element, if uh, let me not the index as anything else, right? If these elements by calls is greater than equals to side, and this elements by rows is greater than equals to side, what will I do for then? What will I do for then? I will say my side equals to result. Sorry, my result equals to side. My result equals to side, right? Else what will I do? Else I will do minus 1. Else check for minus 1. Else side minus minus. Check for side equals to side minus 1. Now, if this side converts to be smaller than result, it will break out automatically. Otherwise, it will just check the 2, then 1, etc., etc., right? So I think that is enough for the explanation part. I think that most of you have got it because you are very intelligent for me also, right? If any problem, you know where to comment, right? Okay. So let us just write the code now, right? So first, to start the code, we will have to subscribe to the channel and we have to like the video, right? Okay. I hope so you have done that. And now what we will do is, we will be making we will be making by rows and by calls matrices, right? Okay. So int by rows, I'm not taking a vector this time because I know the dimensions already. So n comma n, right? Now for int I equals to 0, first filling up the by rows, so n I plus plus. Now int row equals to 0 if it is a matrix, if a of I comma j, that is row column. Now first row, then I will do, oh okay, sorry, I will have to initialize the second row first, right? Nested row. So for it j equals to 0, j less than n, j plus plus, if aij equals to x, in that case row plus plus. Else if it is not x, then what it is? It is 0, and in the case of 0 it will convert back to 0. We had discussed it while solving the problem, right? In that case row equals to 0, that is reset the value, right? And at last, after both of them, I will do by rows of ij as row. Similarly, I will make the matrix for by calls. I will just copy it down because the code is actually mostly same. Let's say call here as 0. J will go from this and just it will convert to AJI. So you can also merge the code in below this nested loop also, right? You can use this nested loop also to work. So it will be call, it will again be call, it again will call, and it will be JI call, right? It will be JI call and it will by calls here, right? Okay, so we have constructed both the matrix successfully. Now it's time to calculate a result. So int result equals to 0. What do? We will traverse from bottom right. Let me make it more clear to you. Let me, yeah. Now zoom in will work properly. So for int I going from bottom right, that is n minus 1 till top left, I minus minus. Similarly for int j equals to n minus 1, j greater than equals to 0, j minus minus. What is the side? Int side equals to minimum of by rows of ij and by calls of ij, right? Okay, now what we will do, we will say while my side is greater than result, what do? If while my side is greater than result, what we will do, if now we'll have to find the index of this element For if suppose I'm here, you can see my cursor, right? If I'm here, I'll have to find the index of this element and the index of this element, right? So whatever I do is I will say if by rows of I minus side plus 1 comma j is greater than equals to side, this will give me the top corner. Like suppose I'm here and I want to find the third corner from this. That this is side 1, side 2, side 3. So this will be I minus side plus 1. Row wise I minus side plus 1, and I have to check the by rows for it if you remember correctly. Similarly, if this is greater than equals to side, or if by calls of I and j minus side plus 1, as we go upwards in the case of by rows, if we will go vertically horizontally in case of by columns, right? Okay, it is greater than equals to side, what do we do? In that case our result becomes equals to side, else side minus minus. Now you can add a break statement here. That is also okay because if side minus minus works, result is already going to be less than side, right? So else side result equals to side, and that's all. At last return result. This was the whole code, guys. So you can see by rows and by calls you should have done on your own because that is not very lengthy and difficult. This complex algorithm is only containing very few lines of code, right? And I've observed many times that the more hard the question is, it is algorithmically more hard, but theoretically and codingly it is not that hard, right? So you can also flourish your mind and go to like reach the heights you have not reached up till now. Okay, so you can see 90 days streak is completed, and hope you liked my video. So thank you for watching, and we'll see you tomorrow in the next question, right?